Before solving this question, we need to recall what exactly an Atwood machine looks like. So an Atwood machine is essentially two masses connected together by a string that is running over a pulley. So what it looks like would be if we have our pulley up here, and then we have one um, rope or whatever it might be connecting to our first mass, and then again going down to our second mass. So in this case, the Atwood machine runs over an object on the left, which is M1, and that has a mass of 8.5 kilograms. And on the right, we have M2, which has a mass of 17 kilograms. M1, 8.5, M2, 17. We're looking to find the acceleration of the masses as well as the tension in the rope. So we can redraw this free body diagram a little bit just to help us out. So if you're looking at just M1, M1 is going to have some sort of force of gravity as well as some tension from the rope. M2 is going to go the other way. The tension is going opposite, and the force of gravity over here. And then, of course, you have to consider the system as a whole. So if you have M1 plus M2, M1 plus M2, then you have some sort of Fg and then another Fg relative to masses 1 and then masses 2. So we can now use this to determine what exactly our equations are going to look like. Let's start off as always with, so part A is that F net is equal to MA. So M in this case is actually the total mass, right? So it's going to be M1 plus M2 times A, and that's F net. We also want to realize that F net, so M1 plus M2 all times A, is going to be equal to our Fg2 minus Fg1. So the gravity on pulling down on one mass and then the gravity pulling down on the other mass. So Fg is obviously m times g. So we can expand this a little bit further and have m2 times the force of gravity minus m1 times the force of gravity. So now that we have all of this information, we can start to plug in some values. So don't forget that we have m1 plus m2a on the left. So m1 plus m2, 25.5 kilograms times our acceleration, which we're going to solve for ultimately here. What is the acceleration of the masses? M2 times g, 17 times 9.8. M1 times g, 8.5, 9.8. So note that you can see down in our free body diagram, the one in yellow here, that Fg1 and Fg2 are in opposite directions. And so that's where this negative sign comes from, because they're pulling in opposite directions. If they're going in the same direction, it would be a sum as opposed to a difference. So this leads us to being able to solve for our acceleration. 166.6 newtons minus 83.3 newtons divided by 25.5 kilograms gives us an acceleration of 3.3 meters per second squared. Part B is asking us to solve for the tension in the rope. So we're going to make use of, let's say, this free body diagram, the one that's highlighted in green there. So we're going to make use of that one so we can solve, knowing that, so our F, of course, as always, is equal to MA. But in this case, our F net is going to be our tension in the rope minus Fg1, because of course I'm using the diagram in green there. I can rearrange this to solve for Ft. So that's going to give me ma plus Fg, which is m1g. I know what a is. I just solved for the previous question, 3.3 meters per second squared, and I have everything else. So I can plug in all of my information, most of which is given to me, but this 3.3 we had to solve from the previous question. And then of course, gravity is always given. We can solve that, and that will lead us to an F tension of about 1.1 times 10 to the 2 newtons.